Hi everyone, Travis May here with the Freshwater Institute. I'm here today to tell you about a tool that's incredibly important for a RAS facility, and that tool is an ultrasonic flow meter. Ultrasonic flow meter allows you to go tank side and strap it onto pipes ranging in size from ½ inch to 24 inches and get a real-time flow readout so that you can fine-tune your system and optimize it. And so today we're going to look at the components that make up ultrasonic flow meter. We're going to attach one to the pipe on the system right behind us, and then do a real world scenario. Flow meters can be stationary, monitoring flow in a header manifold on your system. They can also be mobile, like this GE Transport PT900 flow meter we have here. We like to use a mixture of stationary flow meters for critical flow on your system, but also have the mobile flow meter around so that you can bring it tank side and get flow rates from pipes as low as ½ inch to 24 inches in size. So let's go through and take a look at what all comes along with having a mobile flow meter here. So here we have the Transport PT900. This is the brain of the flow meter. We have an output screen so that we can see the flow rate and make adjustments real time. We have ultrasonic transducers that attach to the pipe and send a signal through the pipe in the water and give us real-time data on the flow rate. We have a compound used to apply on the transducers to get a better signal strength, a communication cable, and some kind of bracket with measurements along the side so that we can hold the transducers in place at the specified distance to get the most accurate flow rate possible. So we've installed our ultrasonic flow meter onto our 4-inch PVC pipe. We have the brain of the flow meter attached to the communication cable, which goes up and plugs into the transducers, which are attached to this bracket on the pipe. And so the transducers are set at a specific length apart from each other, which is set by the manufacturer of the flow meter for getting the most accurate reading you can on a 4-inch piece of PVC pipe. And so when installing a flow meter on a pipe tank side, you want to keep in mind a few items. We want to install the flow meter on the straightest pipe possible with the fewest items on that line that are impeding the flow. So keeping an eye out for valves and angled fittings or reducers. You want to make sure that the transducers are located on the side of the pipe and that the pipe is free of any kind of air. If there's air in the pipe, it'll give the flow meter a bad signal and we won't even get a readout if that's present. And lastly, we want to place the transducer bracket so that it is a minimum of 10 pipe diameters away from the closest 90-degree fitting or valve or any kind of impedance, and a minimum of 5 pipe diameters to the nearest angle fitting or impedance downstream. And so we can see that we're actually producing a flow rate on this pipe, so everything's working fine. And it looks like we're pumping 241 gallons a minute at this time. So we looked at what components make up ultrasonic flow meter. We strapped it on the pipe and got a readout. And now we're going to take a look at a problem we have on the system behind us and try to troubleshoot it. Okay, so our real life scenario today, we'll be looking at this partial reuse system LHO. Staff noticed that the LHO was overflowing a lot of water, and that is a problem because that means we're not efficiently oxygenating all the water that we're pumping. The water that is bypassing the LHO is going to mix down below with oxygenated water and actually dilute the DO out a little bit. So we have gone through and brushed the LHO, making sure that the plate is free of any debris, and we still have an overflow issue. So now we're going to check the flow rate and make sure that somebody didn't change the valve a little bit and increase the pumping rate. Okay, we found the problem. So we're pumping 240 gallons a minute to the LHO when the LHO is engineered to only handle 230 gallons a minute. So that excess water can't flow through the LHO and it's overflowing. So we're going to go ahead and make an adjustment in real time to get that flow back in spec and get that LHO functioning properly. So just a little adjustment on butterfly and we're seeing valve and we're seeing the flow rate react in real time. And so we'll let this sit like this for about a minute or two just to come to equilibrium, and then we'll walk around and check the LHO and see how it works. Now that the flow rate for this system has been returned back to the engineered spec flow rate, you can see that the LHO is not overflowing and we are getting maximum oxygen transfer efficiency.